From ContainerDays Hamburg, this video is proudly presented by DAX IT.
I'm Lea, and I'm a DevOps engineer at Swisscom. Swisscom is a major IT and telecommunication service provider in Switzerland. I'm in a team focused on automations for 5G mobile core deployments. And first, I want to show you how these deployments are usually prepared. This is how we maybe did it some months ago. So first, we would create an LLD. So you see there's an Excel symbol. So this is a very complex Excel files containing all the data needed for these deployments. So it contains, for example, IPs. And then this data was used to prepare anything, so to reserve those IPs in our IPAM. And after that's done, you would create change requests. So you have to coordinate with other teams and give them the information so they can do the configurations. So they would then manually configure, for example, the load balancers, or also log into a node to update router configurations. And afterwards, some manual tests were performed. So here you can see an example of those configurations. So it's quite big. It's here an XML file with a lot of details. And you would check it into Git like this. So it's quite static. And you can see all those details that are part of this configuration. So IP addresses, secrets, and certificates, and much more. So we were wondering, what if this could be more dynamic? So instead of having this entire static configuration, you would basically define your high-level intent, and then you have different smaller parts that do handle the information, and in the end, build the entire config dynamically. For this, we want to rely on a Kubernetes resource model. So this consists of API extensions called CRDs. The CRD contains all the information needed to basically allow you to describe your desired state. Then you can instantiate this custom resource definition with custom resources, where you then describe the desired state you want to have. And the third part is then an operator, which contains your business logic, and it does the automation to get from the actual state to your desired state. And then in NetBox Operator, we also use the claim model, which you maybe know from the persistent volume claim. So this persistent volume claim is, for example, used in stateful sets. So this slide is just an abstraction and does show the relevant parts for this example, but it's maybe not completely accurate. So in a stateful set, you can describe your persistent volume claim template. And then when you apply this to your Kubernetes cluster, for example, with GitOps, the persistent volume claim controller will reconcile it and create a persistent volume claim. This persistent volume claim will then be reconciled by the persistent volume claim controller, which interacts with the backend. And once your persistent volume claim is ready, the stateful set controller will bind it to your pod and create your final pod for the stateful set. So here in this example, you only have the very high-level persistent volume claim, the high-level intent in Git. And when you apply it to the cluster, the details will be handled by the Kubernetes operator. So we'll create the persistent volume claim for you and automatically bind it to your pod. So you don't need to care about these IDs yourself, but Kubernetes will take care of the details. So you can see not all the data is stored in Git, but only the intent. So what do we gain if we combine GitOps with KRM? With GitOps, we have everything in Git, and if you combine it with KRM, the dynamic card can be handled with Kubernetes. This also allows for abstractions. We don't need to have all the details in our configuration. So for example, we don't need to store IPs there anymore, but it can be handled by our automation. It's more flexible. If something changes in our backend, we basically don't need to commit this code to Git, but our operator can reconcile it. It's also easier to scale because you don't need to collect all the data by yourself, but you can describe your intent, and the automation will then collect everything for you. And it also reduces the operational complexity because there are way less manual tasks involved in this. So this talk is basically one part of a talk series about the cloud-native transformation. And here, I'd like to recommend some more talks. Some of them are also like the NetBox Operator talk about a small piece in this journey, and others are giving a more high-level overview. So if you follow the QR code, you can find links to the different talks. With NetBox Operator, which is kind of one piece we need for this automation of our network deployments, we interact with NetBox. NetBox is a network element, an IP address management system that's built for automation, and it's an open source project. You can find it on GitHub. And in NetBox, you can store different information about your network, like cable and racks, or IP addresses and prefixes. So there are different tools you can use together with NetBox. There's the Kubernetes NetBox Operator, which allows you to manage your IPAM resources directly in Kubernetes. It's open source and developed by Swisscom and the NetBox community. Then there's also a NetBox Agentic AI operator from NetBox Labs, which can help you with infrastructure operations. And NetBox Labs also offers integration for Kubernetes, which will basically get your infrastructure data from your Kubernetes cluster and make it visible in NetBox. So in this presentation, I will talk about the NetBox Kubernetes operator. So this NetBox Kubernetes operator is a project we open sourced. We currently support IP addresses, IP ranges, and prefixes in it, and also some elaborate features like sticky IPs. With sticky IPs, you will get the same IP back if you delete your claim from Kubernetes and apply it back to Kubernetes. And as I explained before, we based it on the claim model, similar to the persistent volume claim. So this operator works with claims, for example, the prefix claim. And if you apply a prefix claim custom resource to your cluster, the prefix claim controller will reconcile it. This means it will look at the spec to see what kind of prefix it should claim. So here it claims it from a specific parent prefix, and it wants to get a prefix with length, prefix length 30. Then once it found a prefix that matches these conditions, it will create a prefix custom resource that will be reconciled by the prefix controller. This means that the prefix will actually be created or updated in the NetBox backend. And once it's created in the NetBox backend, the prefix claim will then update the status of the prefix claim custom resource. So also here, you only have your high-level intent in Git, and Kubernetes will then reconcile it, so it will create the prefix custom resource and update the status of the prefix claim custom resource. So the dynamic part will be stored in Kubernetes here. So that was enough from the theory, and I will start with a demo now. So I have a local kind cluster deployed on my computer, and it already has NetBox Operator installed on it. And the NetBox Operator on my kind cluster has a NetBox instance it points to. So usually the prefixes you can use will already be available in NetBox, but I will create this one manually. And for our demo, I want to use the prod environment. So in the first example, I want to apply this prefix claim. So here in the spec, you can see I want to create it for the tenant my tenant. I want to use a fixed parent prefix. That's actually the one I just created with a specific prefix length. And then when I apply this resource to my kind cluster, it should already be reconciled. And we can see we got the first free prefix from this parent prefix. So if I look here at the child prefix, this is the actual prefix that was claimed by the operator. And often you maybe don't have only one parent prefix you could use, but a set of parent prefixes. And for this, we have the parent prefix selector feature. With that one, you can define a filter, which will be used to find matching parent prefixes, and then one of those will be selected to claim a prefix from. So here, instead of the parent prefix field, we have this parent prefix selector, where we have an environment and a family. So the environment is the same as in the prefix I created before, so we will get a prefix assigned from the prefix. So this is the second prefix we claimed now. So NetBox Operator becomes really powerful if you combine it with other tools. For example, in this case, I want to configure a load balancer. So I will use MetalLB, which can be configured with custom resources. And then I need a tool to map the prefix status field from my prefix claim custom resource to this IP address pool custom resource. So this could be a custom-built Kubernetes operator, or in this example, I use the Kubernetes resource orchestrator. Who of you does know this operator? So many of you already know it. With Carry, you can define resource graph definitions. So that's basically a set of custom resources and then mappings between different fields of those custom resources. And once you have configured Crow with this resource graph definition, you can basically add custom resources of that kind to your cluster, and Crow will reconcile them. So in my case, I created this load balancer IP pool NetBox custom resource, and it does the mapping between the prefix status field to the IP address pool custom resource. So that's how it looks like. On the left, I have the newly created custom resource for the resource graph definition. And Crow will then first create the prefix claim. So the name of this resource is the name of the spec from the left, and the spec is basically the rest of the spec. And then, once the NetBox operator has reconciled this resource and the status field is there, Crow will create the IP address pool custom resource that's used for the load balancer configuration. So that's basically the load balancer IP pool NetBox custom resource I showed on the slide before, where we have all the information needed to create the prefix claim and the IP address pool custom resource. So I apply this to my cluster, and then I list the prefix claim and IP address pools I have. So this is the newly created prefix claim. And if you compare it with the IP address pool custom resource, you can see it got the same prefix assigned. So now, as this IP address pool is configured for my load balancer, I can actually use it in my deployments. So I create a sample deployment, so I create a new namespace, an nginx pod, and a load balancer service. So you can see type is load balancer, and I add this annotation to instruct MetalLB to use an IP from this pool we created before. So let's check if it's already ready. So the pods are up, and we got an external IP. So I have a curl pods deployed on my kind cluster, which I'd like to use now to test the IP. So if we curl to this external IP, we can now reach the nginx pods. So with this kind of automation, you can then make the claimed prefixes or IPs available to your configurations. And then I want to continue with another example. So before I mentioned that NetBox Operator also supports sticky IPs. So for this, we have a flag called preserved in NetBox. And if this flag is set to true, the prefix won't be deleted from NetBox if you create the prefix claim, or if you delete the prefix claim custom resource. So for this case, the operator calculates a hash from the prefix claim spec and stores it as a custom field with the prefix in NetBox. This way, when the prefix is recreated later, it can calculate the hash again and look up the prefix by the hash in NetBox. So this is one of the prefix claims I'll create now, and it has to set the prefix preserve in NetBox flag set to true. So here for this sample, I create a new namespace containing 3 prefixes. Good, so all of them are ready now. And now I will delete them and try to restore them. So if I move over here to NetBox, you can see here the 3 prefixes we just claimed. And here under custom fields, you can find the hash, which we will use for the restoration. So I run this command. This sometimes speeds up the restoration a bit. Let's check that all the resources are gone. Yep, and then I can recreate them. So here I recreate them in a different order, so we can check that they are restored by the hash. So if you compare the prefix claim names and the prefixes they received, it's the same as here above. So for these examples, you can find scripts to set up the demo environment on our GitHub repo, and you can also find 2 additional examples there. So one is about the prefix exhaustion. So with the parent prefix selector, you can recover from the case where your prefixes are exhausted by creating a new one with the same set of custom fields. And then there's also an example for a multi-cluster setup, because the NetBox operator can communicate with an external NetBox instance. You can run it on multiple clusters without getting any IP or prefix overlaps. So with this setup, instead of creating a complex LLD, you can define your high-level intent in a custom resource. Then this can be reconciled by an operator that's breaking down this high-level intent into lower-level intents, which are then reconciled by individual operators, like the NetBox operator. And then we also have operators which do directly configure the load balancers and the routers. And then with Kubernetes, we can also rely on events to automate our testing. So with this, we're basically from days to week for deploying a new application to hours and minutes. So our use cases for NetBox operator are bare metal Kubernetes connectivity automation. We also use it for configuring 5G core CNFs. That's also where we need the sticky IPs. So CNFs are cloud-native network functions. This could be firewalls, routers, also REST APIs. It's basically how apps deployed on Kubernetes are called in the telco industry. And then we also use it for VNF configurations. These are basically network functions that are not running on dedicated hardware, but on virtual machines. So if you'd like to learn more about use cases and have some more detailed information, I'd like to recommend the recording of this presentation from Adrian and Alessio about scaling network automation with Kubernetes operators, and this presentation from Alexander and Marcus about intent-based network automation, which is later today. So what's coming out next for NetBox operator? We'd like to expand it to more use cases. Also discuss its uses in the Silva project. We'd like to evaluate KCP integration for multi-tenancy. And we would also like to support community use cases. So yeah, get started now by trying out NetBox operator and also automating your infrastructure with KRM. So if something's missing for you in NetBox Operator, please create an issue or a pull request on GitHub. So thank you for being here, and I'm ready for questions now.
Let's go for the two first one. Do you consider crossplane instead of CRO plus the custom operator? And if yes, what were the reasons against it?
So I wasn't looking in the crossplane option. So yeah, I think CRO for us was simpler to get started with. And yeah, I used it in this demo. So for the other cases, we have our custom-built operators.
And the second one is there an integration plan with Nethio? I don't know what Nethio is, to be honest.
Yeah, I'm currently not aware of it, but we could look into this.
The last one for now. Keep questions coming. Come on, we have time. Can you add additional labels or other labels to the IP prefix claim?
Like in the parent prefix selector? Or, yeah, there basically all the custom fields are available, and some from the built-in NetBox fields. And it could be easily extended.
Ah, there we are. Thank you. How hard it is to support new NetBox resources?
I think if it's IPAM resources, it's quite easy. And for other ones, we would have to see. But in general, it's not a lot of effort to add new resources.
What if someone is changing manually NetBox? Will it be reconciled or overwritten from the operator?
Yes, so I mean, it depends a bit on how you configure your operator, how often it reconciles. But once it reconciles, it would overwrite it.
Slido is empty. Help us. Come on. Any question in the audience? Someone who want to get the mic? We have two now and they're working. Nobody? Three? Ah. You're waiting for the last second. Okay, I got it. Is there an option to avoid that, like how the external DNS does it with owner records? Is there an option to avoid what? I think we're missing some words there. Get the mic.
So if I understood that correctly, if something changes in NetBox, it would override that. But is there like some kind of collision avoidance? So if I have like two operators running in different clusters and they're not talking to each other, and I'm requesting, like IP ranges from similar, a sub-range from an IP range, then you could get collision, right? Or is that avoided by NetBox itself and the operator doesn't even touch that?
Yeah, exactly. So the NetBox operator does then basically block the prefix or IP it uses in NetBox. So if a NetBox operator from a different cluster would request a resource, it cannot get the same one.
One last question. I won't buy you a coffee, I'm sorry, but one last question. Yeah, great talk, absolutely. No question then? 3, 2, 1. Thanks a lot for the talk, Lea. And please, a round of applause for her.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.